Revision of a linear graph or linear function. Over here, the question is asking us to draw the graph 2y plus x minus 8 equals 0, and then determine all the significant characteristics of this linear function. A linear graph refers to a straight line graph. And we know that this is a straight line graph because x has the power of 1. So over here's our x, its highest exponent is 1, therefore it's a straight line graph. The first thing we need to do to answer this question, in other words, to sketch the graph, is we need to write this equation in standard form. Now, standard form refers to the form y equals mx plus c. So let's take this equation and rearrange it. We start at 2y plus x minus 8 equals 0. You want y alone. There are a couple of items that's attached to this y. We have the 2, or let's do it like that. That's a multiplication relationship. Then we have x, which is addition, and we have 8, which is subtraction. So we need to remove all of them. You are going to take the addition and subtraction away first before you deal with multiplication and division. So what we can do is, let's go ahead and do the opposite of the x, which is going to be, so it's plus x, we're going to say minus x on both sides. And the opposite of minus 8, we're going to say plus 8 on both sides. So what we're left with is 2y is equal to negative x plus 8. Okay, very good. Let's get rid of that 2. So what we do on both sides is we're going to say divided by 2. Which means that now you have y is equal to, let's stick to one color, negative x over 2 plus 8 over 2. Now, all three of them have been divided by 2. That's what I'm trying to show you in that line. Let's simplify. Negative a half times x plus 4. Now, I need to point out that these two statements here mean the same thing. Negative x divided by 2 is the same thing as negative a half multiplied by x. So since x is a numerator, I can take it from the numerator and put it next to the fraction as a whole number, as a numerator by itself, multiplication. Okay? So this is the first thing we've done. We've got our equation in standard form. Now, in order to draw it, let's do step 2. We are going to draw. In order to draw, there are different ways of drawing the graph, but we're just going to draw from the standard form, which means I'm not going to look for points to substitute. I'm just going to use the equation. So using this equation, I can use this positive 4. This you should know as your y-intercept. This is going to be where I start. So my starting point is going to be on the y-axis at point 4. Now over here, I have my gradient, m, which is the gradient. Now, if you remember that m is equal to your change in y divided by your change in x. What this means is that our y change possibilities can be up, down, and our x can be left, right. How do you know which direction to take? Direction is determined by the sign. So now I have negative a half. What does this mean? This can mean either negative 1 over 2, or it can be 1 over negative 2. That minus sign goes to one of the two. But now I need to decide which one. Does it matter? Let's have a look. So if it's negative 1, it means I'm going 1 down, and then I'm going 2 to the right. Okay, so 1 down and 2 to the right. That's what the top fraction means. The bottom fraction will be 1 up and 2 to the left. Okay, so I'm going to do both of them. Let's do the first one. Okay, so if I start at 4, I start at 4 because that's my starting point. Okay, let's sketch in a light blue for you. Okay, I'm going to start at 4. Now I'm going to go 1 down. So I'm using the top fraction. I go 1 down, which takes me to 3, and I go 2 to the right. 1, 2 to the right. I put an X over there. Again, 1 down and 2 to the right, put an X over there. 1 down and 2 to the right, put an X over there. 1 down and 2 to the right, put an X over there. If I do the second fraction, the bottom one over there, I'm going to start at my 4, and I am going to go 1 up and 2 to the left. Again, 1 up and 2 to the left. A third time, 1 up and 2 to the left. What I would like you to see is it doesn't matter which of the two fractions I use, I get the exact same line. So now, because I'm sketching on a tablet, I'm going to struggle to get a straight line, but I need you to use a ruler, please. This, ladies and gentlemen, is going to be your straight line. So this is the Y graph. Remember to label your sketches. Other thing, please draw to the edge of the Cartesian. Do not draw a short line. Okay, we have done the first part of the question to draw. That's what we've done. Now the second part of the question is asking us, what are the significant characteristics? And this is something that you need to be able to answer on your own. If we're talking about sketching a straight line graph, significant characteristics are going to be your x-intercept, your y-intercept, and your gradient. Okay. In addition, we will also look at your domain and range. So let's have a look. If we're talking x-intercept, y is always equal to 0. Y-intercept, x is always equal to 0. Gradient is your m value in your equation. All of these can be taken from, well, not all of these can be taken from your sketch. So let's have a look. If I'm looking at my x-intercept, x-intercept for me is going to be where y is 0, which is on this line. So my x-intercept is this point over there. X-intercept is positive 8, y is 0. My y-intercept, x is 0. So if I do the y-intercept, it's going to be on this line, on the y-axis, and it's at that point. It's also in the equation, which is 4. So I don't even need to look at the graph for that. And then lastly, the gradient, as I mentioned before, gradient is m, which is negative 1 over 2, and you get that from the equation as well. You can also get from the graph. If you go from here to here, that will be negative 4, and then from here to here, that would be positive 8. So negative 4 over positive 8 gives you negative 1 over 2. That is also your gradient. Now let's talk domain and range. Okay. Question, we're still part of 3, so let's say domain. Domain is going to be all of your x values, and range will be all of your y values. Okay, so if we are looking at the domain on a straight line graph, there are no restriction given. So this means that this graph continues forever and ever and ever. Your x values, this is your side to side, will never end. So our domain is going to be x, so curly bracket, x colon, x is an element of all real numbers. That would be your domain. Your range is going to be curly bracket, y colon, y is an element of all real numbers, close curly brackets. Neither of them will stop. It goes from infinity x to negative infinity to positive infinity x, and it goes from negative infinity y to positive infinity y. Now, how would you describe this gradient? This means that this is a decreasing function, and that statement or the phrase decreasing is attributed to the fact that it's a negative. Notice also that your graph is going in a top to bottom direction. Since it's a decreasing function, it means that as x increases, y decreases. Okay, oopsie, what happened? Okay, so this is how you do just a quick recap of the linear function.